Hello and welcome back. Please remember to complete all assignments and discussions in the module before the posted due date. Keep up with the assigned readings, and as always, contact me with any questions. In this lecture, we will discuss the pelvis, legs, and feet. So let's go ahead and begin with the pelvis. We have three bones that form the pelvis. You have your sacrum, and then which we've already talked about, and then you have your innominate. But there's two innominates. The innominate is paired. You have one on each side. We've already discussed the sacrum, so let's focus on the innominate. The innominate consists of three different sections. You have the ilium, the ischium, and the pubis. And these ossify around 12 years of age, but this ossification could be delayed until about 17 years in some individuals. The innominate is a key bone for calculating sex. Several features on the innominate are used, including the greater sciatic notch. This greater sciatic notch, as seen here, we have different ways that we can measure it. If it's narrow, it's typically thought to be more male. If it's broad, it tends to be more female. So that's one of the features. Now, when we're estimating sex, we don't want to just look at one single feature. The more features we have, the more reliable our sex estimations are. So let's take a look at another angle here. This is the subpubic angle. The subpubic angle is that angle where on the front of the two iliums, ischiums, they come together and it forms this angle, essentially. If you take a look at the dotted lines in these two images, that dotted line measures that subpubic angle. If you see the angle above it, the triangle that's formed. Now, a narrow subpubic angle is thought to be more male. A broad subpubic angle is typically more female. Finally, there's also the general appearance of the pelvis. A narrow pelvis tends to be more male, and a broader pelvis tends to be more female. And this has to do with aiding in childbirth. If you're going to pass a child through there, you want that pelvis to be as wide as possible. So keep in mind that natural variation does exist among the different sexes and among many different people. So this is why it's best to calculate many features and not just one or two. So let's move to the next bone, the femur. The femur is the longest bone in the body. It is paired. You have one on each side. So femur is actually the singular, the term for the singular, and femora are plural. So we say we have one femur or we have two femora. There are several important features on the femora. The first is the femoral head. The femoral head articulates with a feature called the acetabulum. The acetabulum is the socket on the innominate. So that's another feature you're going to need to know. The head of the femur, has a distinct feature called the fovea capitis. The fovea capitis is this divot inside on the femoral head. This is actually the attachment point for the ligamentum teres. It holds your leg in its socket. It's essentially the spot that holds your leg in from dislocating from the acetabulum. So that fovea capitis is that feature on the femoral head. Another key feature is the patellar surface. This is where your patella, your kneecap, articulates. It's located between the medial epicondyle and the lateral condyle. So we see the patellar surface only on the front side, on the ventral side, not on the dorsal, not on the back side of your femora. These are very important features to help us side the feature as well. We can side the feature of the femur as being a left or a right femur based on the angle of the femur. If we look in this image here, you see this little bit of an angle from the femoral, the distal femora heading up toward the femoral head. That little bit of an angle to the left or the right helps us know if we have a left or right femur. When we stand just relaxed with our feet below us, our knees are actually kind of slightly below in a little closer to each other than the femoral heads. So we have a little bit of an angle on the femora. All right, so this is pretty important. what bones in the distal femur, what bones do the distal femur articulate with? Well, the distal femur only articulates with one other bone, and that is the tibia. The tibia, you have it does articulate with the patella as well, but don't worry too much about that. They're kind of, it's held in place. The patella is held in place by a lot of ligaments here. So we're going to think more about the tibia here. The medial and lateral condyles articulate with the femur, and the tibia is a paired bone. You have one on each side. It's found on the medial side of your leg. So when you, if you feel down on your left leg, the inside of your left leg, you feel that up high, you feel that nice, hard, sharp edge. That is your tibia. And if you feel the outside of your lower limb on the left side, or the outside on the right side, you'll feel that that's a lot more muscle in there. That's where you have your fibula, but it's buried among all that muscle. So the tibia is medial. It's on the medial side of your lower limb. The distal tibia has a distinct feature. This is called the medial malleolus. And this medial malleolus, it's not a process that sticks off. It's an actual distinct feature. It actually anchors your tibia within your ankle. So that medial malleolus helps you to hold your foot articulated to your lower limb. The proximal tibia articulates with one other bone, and that is the fibula. The fibula articulates on the lateral side of the tibia, so it's on the outside. The fibula is a paired bone. You have one on each side. It's very narrow and very long, and if you ever broke your leg, you likely broke your fibula. You may have broken your tibia, you may have broken your femur, which is a very, very hard bone to break, but you can break it. But most people, if they break their leg, they break their fibula. It's a relatively delicate bone surrounded by muscles. You can break it. In fact, in a lot of sports injuries, especially in football, our fibula breaks, because when you're getting tackled, you're tackled from the side and it kind of breaks it that way. All right, so let's begin with the foot and ankle. Let's get down to the feet. Here we have to think about the foot and ankle in a similar way to the wrist and the hand. The ankle and foot is very, very complex. It includes 7 tarsals, not carpals. Remember, we had 8 carpals in the wrist. Well, in the ankle, you have 7 tarsals. You also have 5 metatarsals, not metacarpals, but metatarsals, and then 14 phalanges. So let's go ahead and we'll begin with discussing the tarsals. The tarsals are grouped in 2 rows with 1 outlier. So our first row has 2 bones. It's the talus and the calcaneus. And our second row, the distal row, has 4 bones. The first cuneiform, second cuneiform, third cuneiform, and the cuboid. Between the rows on the medial side of the foot is the final bone, and that's the navicular. So there you have your 7 different bones in the tarsals. Now next, if we're extending further away from the body, we have our metatarsals. We have 5 metatarsals in each foot, so that they're paired, so you have 10 metatarsals in total. Proximally, they articulate with the tarsus, with the tarsals. Distally, they articulate with the first row of phalanges, the first row of your toes. So your metatarsals are just like your metacarpals. They are miniature long bones. They form the body of your foot. And beyond your metatarsals are your phalanges. These are your toes, and there are 14 phalanges in each foot. You have 3 phalanges per toe, except for your big toe, which only has 2, just like your thumb. All right, that's it for this lecture. So please let me know if you have any questions, and make sure you complete all discussions and assignments that are posted within the module. Thank you.